Alright, one is August 21st. Alright, so the plan is we're going to finish this one, which is today's challenge, and then go back to stamping the sentence. So last night was finally able to finish this problem. Tough, really tough. You can see I have like 7 attempts and trial and error, but the solution we eventually found was quite good, comparing to a year ago where we followed the official solution. I mean, the test cases might change, so I'm not actually 100% sure if this one is better, but just based on the runtime, we're like 6 times better than four to 6 times better, right? And I have this is how I approach it, but this is the solution from the last time. So I'll go through this. I want to go through this, so kind of see how the thought process was in the past. This is probably from the official solution. So we're going to do that, and after that, if we have time, we're going to go do the minimum number of refueling stops again, right? Again, because there is a priority queue solution. So I'm going to go through that. So a lot of things. Power of 4. Given an integer, return true if it is a power of 4, otherwise return false. Alright, I think we'll have time today. This one is not difficult. I mean, depending on what type of solution do you allow, right? I would just do a log. Do a log. Not really a log. What would be a... Oh, could you solve it without loops or recursion? Ah, I see where this one is going. I see where this one is going. They're trying to go for binary. The binary representation of a number. What is 4? So that's 1, 0. That's 2. 1, 0, 0 is 8. 1, 0, 0. Wait, hold on. How much is 4? 1, 0, 0 is 4, right? Yeah, 1, 0, 0 is 4. So what's 16 is 2 to the 4th, right? So I'm gonna go 1, 2, 3, 4. It's 1, 0, 0, 0, 0. So if it's power, what is power? So 1, 0, 0, left shift. Hold on. So 4 to the x is 2 to the 2 to the x, which is 2 to the 2x, which means we need to left shift even number of times, which means we need even number of zeros. Alright, because you go 1 time, that's 1 0. If we go 2 times, that's 2 0. So what we need is turn the number into binary and count how many zeros there are. And it has to have a leading 1. Okay. So what will be the easier way to do this? We can count. Yes, we can count. Count the number of ones. Okay, so we will count the number of ones. So we're gonna go binary n. I think that's because it has a b to it. Actually, I forgot. What's the binary look like? Zero b, so 0, 1, 2, right? So go 2 to the n, And we just say bstr equals this, and we want bstr.count 1 to be equal to nope. We want bstr 0 to be 1 and bstr.count 0 to be len bstr minus 1. That's what we want. So we return this and this. I think this shall do. Now 16 is true. 5 is false. 1 is true. 1 is true. Yep. 1 is true. Is power of 4. Okay. Oh, I forgot the even. Shoot. My bad. Oh, then what we can do is this equal to this and len bstr must be odd. Then 2 will be false. Can't believe I forgot. I was just talking about this has to be even, which means the total length has to be odd. There we go. That's the one. 780 days. Could have not have this error. This is not necessary. Yeah, it's too fast. 342. The binary version, the binary of n must have 1 at the, is that the least, no, most significant bit, and even number of trailing zeros. Okay, so we're done with today. On this one, let's go back to yesterday. Look at this bloodbath, total bloodbath. Okay, so this is the other solution. All right, we're now going to read. We'll just read our code. So we have stamp, and I turn target into a list. First run. What am I doing here? N minus n plus 1. Okay, I see what I'm doing here. So for j in range, okay, n is the stamp. If t list, target list, I plus j is not equal to stamp, and this is not equal to, I think we are replacing everything with the star. Right? Like if we go through the whole thing, now we replace, okay, I see what I'm doing, and I put I into it. Okay, I have a better way to do this now. We have something called find, right? We can use something called find. So we know what this is. It's find. No, not here. Here, fine. See? Much simpler way of dealing with this. Hold on. What is this? Why the last one has to be a star? Yeah, I don't understand this logic. What is this? The last one, if it's not star, then I return. Who said the last one has to be star? Hey, really? This one works? Hold on. What are we doing here? I find it first and I move forward. I see. Now I see what is going on. Holy crap, this is already matching the suffix, right? We just say for n, for like the window of n, we try to match, right? The match the first match will definitely require everything to match the stem. But once we find the first match, notice we only move forward one step. And when we match again, a lot of already matched will become this. Then we are matching the suffix. You see what I'm saying, right? We're matching the suffix. So when we go through this, we are matching all the suffixes. Like all the suffixes will be matched. And because we are matching suffix, the last one must be matched. Yes, understand. And I understand that. And then the second run, are you saying we're going to try to match prefixes? We're going to start from and. Okay. So we skip all of this. And if this break, that's just mechanics. And for anything that's not, then we're going to try to find prefixes. So we say for I in range from and, what is this? Minimum of this plus 1. Minimum of and n minus n plus 1. And for j, and we do the same thing. Huh? So the and when we come out, that is the first and when it's not a star, right? So the first and that's not a star, aren't we supposed to try to match the prefix? Then I say, I'll go from the very beginning and we'll end at that. Okay. And we can go through J. Let's go slightly windowed again. Oh, there's a lot of repeated action that's actually not necessary. I just realized. So we have, it's the same thing. We try to match, and then we're allowing the star. Whenever we fail to match, we just get out, we keep moving. Else, which means we find a match. I go through everything again and see if any change has been made. If any change is made, I will append. Enjoy. Okay. That makes sense now. But we'll do repeated things. Yeah, I see. Okay, so I understand this. So once we go through the entire thing, we check again. Oh wait, not check again, we check the end to see if it has been changed. I see. Is this one easier or harder than this? A lot more steps for sure. But this is actually a great way, right? This is a great way to find suffixes. It just takes a long time. And I mean, I don't think we have much optimization that we can do here. Just going through and going through everything. And we might be able to, you know what, I think this can be optimized. We don't have to go through the entire thing. Yeah, you have to. Otherwise, the logic will be too convoluted. So we just go through the entire thing. And then all the suffixes is done. Now we're just going to go the other way. Right? From right to left. And we're going to handle prefixes. But I believe the prefix can be handled slightly differently. Right? So what I'm thinking is, we go right to left. We find the first one that's not being matched. Then we can go from here. It could be this. Right, we can follow the same logic. Just this, 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 this. And then we try to get the largest. Yeah, we can do that. Now coming back to this solution. Now this one. The benefit of this one, we're using a Q. Yeah, you know what? Actually might not be as... Okay. I want to write this one myself. I have enough test cases. So, actually they might not be accurate. Do I have test cases in the... I don't have all the test cases. But it's okay. We can create all the test cases. Let's try this. I want to make it slightly better using the current understanding. Okay, so this is from the solution a year ago, but with my current touch to optimize it. Alright, so what do you think? And the beginning will be the same. We'll do this, right? Of course, the length I want to do slightly differently. I want to say m and n, which right now makes more sense to me. Then we're going to do the first scan. Perform all suffix matching for I in range. So we're going to go to an index such that n minus 1 minus this index plus 1 equal to m, which means this index equals n minus m, right? So n minus m, that's the index, we have the plus 1. And for j in range m, then we say, right, as we go through, we say if target, we have to do this, target equals target equals list target, because we have to make changes. So we say if target what? I plus j, right? If this is not equal to stamp j, or target this plus j is not equal to, I like to use this, then break. And then when we break, we just go for the next one. And else, if we go through the entire thing, then we say for j in range m, we set everything, I plus j, we set everything to question mark. So that's the first scan. We did all the suffix matching. And after we're done, we say if target minus 1 is not equal to this, then return this. Since all suffix matching is done, the end of target should have been matched. Makes perfect sense, right? It makes perfect sense. Okay, now we say the second scan, perform all prefix matching. Greedily. I mean, this one, we can say if the start, if we create a prefix and suffix, then we can like after the first, it's just, it'll make the code a lot more complicated. And this one we're doing repeated work, but the readability is better. You see, I can see the argument. So we're gonna say I equals n minus 1 as the start, right? We say while I large equals to 0 and target I is equal to this, I minus equal 1. So we go. If I is smaller than 0, now I break, right? I think it was true. And then we find the first one. Then what do we do? we say prefix matching, right? Then we just say from this going back. If it matches, we turn that. If we match, then we turn that. If we match, I think a better way, right, will be I have a better idea. I still like this. And then we'll produce a left and a right. I'm gonna go brr, 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 brr. So we can actually do find. No, hold on. I can't merge these two methods. Because the first one, doing suffix matching, is just so, how should we put it? Suffix matching is just so straightforward. But we are wasting a lot of time. That's my thing. You know what? Maybe we can do it with a prefix. Let's just do the suffix this way. And then we do the prefix. I think prefix might benefit it more. So blah, blah, blah. So now we have the first one. Then we have to go from this I. So we get this, up until we cannot get. And every one we're going to try. Right, we try this. And now we find the longest prefix. And then we will record the left. Right? And then when we record the left index, that will be the overall index. And then we set this whole thing into, then I don't even have to turn them into question mark, right? There's no need to turn them into question mark. We just start from this. Start from where? Yeah, we start from this, and then we just try to see. Then we have this, then move everything forward, So the prefix matching can be optimized. I mean, the suffix matching, it can be optimized as well. But, yeah, we can say just, I don't know. Yeah, let's just optimize this one. Then we say left equals, so I is the first one that's not equal to question mark. So we say this equals I plus 1, right? And then we say for, so no, while and left is larger or equal to something. So what we want is, this is the prefix, right? So we say left, and the right should be I, minus this, plus 1. This one should be smaller than m, right? But larger equal to 0. It's I plus 1 minus m, so left should be larger than this. And 0. So we can say larger than the maximum with minus 1 and I plus 1 minus m. Now this would be j. J equal to I. Or we can say for j in range I this minus 1. Okay. Say if target from j to I plus 1 is in prefix set left equal j. Blah blah blah, are we done? We say if left is equal to I plus 1, then return this. Otherwise, oh, what is the result? Shoot. So now left is the actual index, right? Then we can say rest.append left, right? So like left, so this part is matching. Then I shall equal to left minus 1. Then we keep going, and eventually when we got out, we say return rest. Alright, let's see if this one works. Solution 2. Nope, doesn't work.
Oh.
Oh. Alright, let's see what we get. target result. Ooh, that is interesting. Huh. What? That's correct. So I never hit this one. That's interesting. ABA. 012. So? What the heck? Zero, yes. One, yes. 0, 2. But that one is matching, right? Target this. Yeah, these two are matching. So if this equal to this, oh, I think should be and. Yep, shall be and. And I forgot to reverse it. Yeah, I don't think all of them are correct. Right, number 6 is definitely not right. Zero, A, B, C, A. 3, A, 0, 1, 2, 3, A, B, C, A. And a 1. Yeah, that's actually fine. Yeah, actually, we should put these in this test case. Yeah, this one is definitely wrong. But kind of just feeling how the other one goes. No, not this one. Come on, man. Well, actually, this one doesn't. Oh my god. Let's just remove this. Okay, so we have the error in this one. Okay, so we just need to focus on this one. So what do? We first definitely get target the rest out. So we have this result, pretty good. And then we're going to do this. We have a prefix set, that's perfect. It should be always right. And then we go from the end. So that will be first stop will be B, right? So let's say print I and target I. I probably just go target I. B, yes. And then we say left gonna be I plus 1, so left I put it here, just to know. And then J is gonna be from this, right, towards, doesn't matter, however much we're gonna go front. And we say target J, so which just means this, to I plus 1. I plus 1 is here, so this is in prefix set, right? That should be in the prefix set. Oh, prefix set. I see the problem. You cannot do that. That's why we have to use whatever method that was used. I see. The size issue. So now we're going back to the same sizing issue. Might as well just use the old metric instead of doing this. Okay, so nope. We're not doing this with it. So what's the old trick? I shouldn't delete everything. We'll have the I, and we don't need to do the prefix set. And then say blah blah blah. These are fine. So we have the first one. But what we can do, right, is go from the leftmost, and then we go. With the first one that does work, then we stop. So we can still optimize it a little bit, which means we're gonna say for J in range, we're not gonna go from the front. We're gonna go from the maximum we can reach back. So we're saying I plus I minus, maximum 0 and 2, right? So from this all the way to I plus 1, this is what we can do, right? And then, for J, you kind of don't want to use J, right? So K, in range M, of the same thing. Then what do? We basically say if target J plus K is not equal to stamp K and target J plus K is not equal to the question mark, Then we're going to break. Else. So we go through the entire thing, and then we do an else, which means we've found, right? Which means we have found. We have found the prefix. Then we simply just say for k in range m, if target j plus k is not equal to the question mark, then target j plus k equal to the question mark, else we're going to break out. So already filled. Once this is done, rest.append j. Okay, because from j to towards the end, and then we find, right? And then we're going to just append j. And I like to say just moving on. I shall equal to j minus 1. And I'm going to break again. Does this work? I have something. Let's try it. I think it's solid. So we are optimizing here. So prefix matching means the rest must all be this already. Greedy. First match is the longest prefix match. We only want the longest. We only want the longest prefix match. Okay, let's see if we can get some performance boost. Submit. Must be the second part. Yeah, trying to optimize. This is what happens. So what do? We are going to comment out this entire thing. Apparently, it might be because I didn't handle it. So let's say this we found, right? else we found, blah, 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 blah. So if we go to the entire thing, that we don't find anything else, then return this. Okay. Yeah, this is fair. It's totally fair. Yeah, this is basically we cannot find anything. Exactly. We reduce the amount of trouble going here so we can make it faster. But actually, we should run this one again. Let's see how it goes. But I have no intention. So yeah. Okay, cool. It worked, right? It worked. But still, this is pretty darn difficult one. Yeah, it's in the nightmare. Jeez, come on. Hard. Very, very hard. Alright, I will see you guys tomorrow. So we still have this minimum number we haven't done yet. We haven't reviewed it yet. Alright, see you guys tomorrow. Adios.